A very good morning to all of you. This is the ninth video from the unit Arithmetic Progression, and here in this I am going to discuss very important questions. And here in first I have, in a given AP, if pth term is q and the qth term is p, then so that nth term is p plus q minus n. In solution, let A be the first term and D be the common difference of the given AP. Then pth term here I have equal to A plus P minus 1 into D, and qth term it is equal to A plus Q minus 1 into D. Since in the question it is given pth term it is equal to Q and qth term it is equal to P, so we have A plus P minus 1 into D equal to Q. Assume this as equation 1, and A plus Q minus 1 into D equal to P. Assume this as equation 2. Now on subtracting 1 from 2, we get, just do it carefully, Q minus P into D, it is equal to P minus Q. That is, D is equal to minus 1. And therefore putting D equal to minus 1 in equation 1, we get A equal to P plus Q minus 1. Thus, now we have A equal to P plus Q minus 1 and D equal to minus 1. And as we know, the nth term of the AP, it is given as A plus n minus 1 into D. So putting the value of A and D, I have here P plus Q minus 1 plus n minus 1 into minus 1. After simplification, it is equal to P plus Q minus n. Hence, the nth term it is equal to P plus Q minus n, which we were supposed to prove. Moving to the next question. And here in the question, if the pth, qth and rth term of an AP be A, B, C respectively, then so that A into Q minus R plus B into R minus P plus C into P minus Q is equal to 0. Please note this question first. Now moving to its solution. Let X be the first term and T be the common difference of the given AP. Then we will have the pth term, it is equal to X plus P minus 1 into D. Qth term equal to X plus Q minus 1 into D, and Rth term is equal to X plus R minus 1 into D. But in the question it is given that pth term it is equal to A. So we have X plus P minus 1 into D, it is equal to A. Assume this as equation 1. And qth term it is equal to B. So we have X plus Q minus 1 into D equal to B. Let this as equation 2. Now Rth term it is given equal to C. So we have X plus R minus 1 into D equal to C. Assume this as equation 3. On multiplying equation 1 by Q minus R, do it carefully. Equation 2 by R minus P and equation 3 by P minus Q, and adding these we get A in bracket Q minus R plus B into in bracket R minus P plus C into P minus Q equal to X, then bracket start, it is Q minus R plus R minus P plus P minus Q plus D into P minus 1 into Q minus R plus Q minus 1 into R minus P plus R minus 1 into P minus Q, and this whole multiplied by D as it is given here. So now this is equal to X into 0 plus D into 0 and finally it is equal to 0. Just observe it here carefully, and hence we can say A into Q minus R plus B into R minus P plus C into P minus Q, it is equal to 0. Moving to the next question, and here in this question I have, if the mth term of an AP be 1 by n and its nth term be 1 by m, then so that its m into nth term is 1. Again, for its solution, let A be the first term and D be the common difference of the given AP. Then mth term, using the general formula, we have A plus m minus 1 into D, and nth term A plus n minus 1 into D. As it is given in the question, mth term it is equal to 1 by n. So we have A plus m minus 1 into D equal to 1 by n. Assume this as equation 1. Also in the question it is given nth term it is equal to 1 by m. So we have A plus n minus 1 into D, it is equal to 1 by m. Assume this as equation 2. On subtracting equation 2 from equation 1, we get m minus n into D, it is equal to 1 by n minus 1 by m, which after simplification equal to m minus n whole divided by mn. So we have D is equal to 1 by mn. Now putting D is equal to 1 by mn in equation 1, we get A plus m minus 1 divided by mn, it is equal to 1 by n. So this implies A is equal to 1 by n minus m minus 1 divided by mn. So after taking the LCM as mn and simplifying it, we will have 1 by mn, that is A is equal to 1 by mn. Both A is equal to 1 by mn and D is equal to 1 by mn. Therefore, finding the m into nth term, we have, using the general formula, A plus m into n minus 1 into D. Putting the value of A and D, here I have 1 by mn plus mn minus 1 divided by mn. So it gives equal to 1, and thus we have